Hello, we are JDL Aquatic Solutions, and this is our proposal for the next generation of reliable, sustainable, and electric water transportation.
My name is Dawi Barros. I'm a second year student at the University of Washington studying sociology and human-centered design engineering. And to this program, I bring in my experience with graphic design, illustration, and web design.
My name is Jaden Fan. Next year, I'm going to be a freshman at the University of California, Berkeley, and I bring to this program my experience in robotics, the engineering design process, and 3D design.
And we are here together in our passion for creating sustainable technological solutions to solve world problems. The root of our problem is climate change. According to climate.gov, the global mean sea level has risen 8 to 9 inches since 1880. This is primarily due to industrial civilization and the use of fossil fuels in Western countries. However, those who are most affected due to these rising water levels are those who live in small island nations or in coastal regions such as Malaysia and Indonesia, who have been increasingly vulnerable to natural disasters with limited resources to defend themselves.
A proposed solution to this problem of rising water levels has been to have man-made floating islands that provide energy and education to the communities. However, current popular water transportation solutions are not reliable, ecological, renewable, or sustainable, and especially not optimized for student transport or school usage.
As JDL Aquatic Solutions, we propose a new form of reliable, sustainable, and electric water transportation. By no longer relying on external gas companies to import fuel to the area, our water transport will be able to harness local electricity generators from floating islands and solar panels, which would therefore eliminate fuel costs. This form of transportation would be simple and easy to manufacture and maintain due to the design and nature of electric propulsion. Electric vehicles are simpler than combustion engine vehicles by nature, but they also have the benefits of being quieter, easily recharged, and not releasing harmful emissions. However, if energy does run out, we have considered backup manual rowing or sailing capabilities so that it's never stranded.
When designing the physical watercraft, our group first made a series of rough sketches to get our ideas onto paper. We then debated the different features of the sketches and then combined them, developing them further in 3D software. We combined the two-hole design from one sketch with the more sleek design from another for increased stability and aerodynamics. We also decided on a simpler boat shape for a familiar and safe feel, while also being easier to manufacture and maintain. Once we created this 3D model, we then sent the files to Seattle makers to 3D print and laser cut these parts, which allowed us to see what our watercraft actually looks like in a physical form. And as you can see, I think it worked out pretty well. I can almost imagine people walking down the aisles and sitting in the seats.
When considering our design, we thought of multiple failure possibilities. We would need to test, then did what is called design failure mode and effect analysis, or DFMEA. We considered events such as the center of the boat collapsing due to the double hull design, damage from rock and debris hitting the hull, the battery overheating or catching fire, water leakage, and even the possibility of someone falling over the railings or the railings collapsing from weight. We then came up with hypothetical ways to test each of these if we did go on to further develop our product. As for the issue of the center collapsing, we plan to conduct a shock absorbance test that would measure the extent to which the center can sustain physical stress. We would do so by testing the boat and making sure that it resists any shock with a residual force that doesn't exceed the standards as enforced by law.
In order to test the consequences of rock and debris impact, we can use a gravelometer to propel gravel at the holes and see how much damage or leakage ensues. To test our batteries, we can put them through a series of battery stress tests to see how much they overheat or fail. We can also test how well our hulls work by potentially putting them in water or putting them through pressure tests to see if they leak. Finally, we can also make sure our railings match all official guidelines and can withstand forces without breaking.
In regards to the market, PR Newswire reports that the global boat market would rise by 11% just in the next 4 years, with Malaysia being among the top marketplaces. Due to such increasing demand and relatively shorter supply, presumably due to the importation limits and currency inflations, the costs are very high. For instance, Boats in Langkawi and Penang, which are regions in Malaysia, are selling for a range between 200,000 to 700,000 depending on their production years. Demand for the product is also increasing due to the loss of terrestrial surface due to the rising sea levels.
Our target market is governments and government agencies that are interested in investing in water transportation. As Dawi said, places threatened by rising water levels like Indonesia and Malaysia will be especially interested in our product, whereas cities like Jakarta are sinking rapidly. In addition to solving critical transportation problems for these locations, our product can also be used to generate additional revenue for our target governments through commercial tourism and public transportation.
Moving on to the go-to-market strategy, we plan to conduct our marketing in the Malay language, which is the native language of Malaysia. We hope to focus on the age range between 25 and 54, which comprises 40.8% of the population. Our secondary focus will be on children aged 14 or younger, which will presumably our stakeholders as students, which also comprise 26.8% of the population. In addition, we would also market it to tourists through promotional flyers to attract them to places that hold our product. In terms of pricing, we hope for the fully developed product to sell between $200,000 to $300,000. As for the marketing platform, we hope to advertise it through online media because Malaysia is increasingly being cosmopolitan and the population is relying on online sites for shopping. We also hope to demonstrate our product in person for our primary stakeholders in order to spread awareness of electric water transportation to the public.
Globally, there are a few companies that we would consider competitors, including Damon Engineering, Tracia Engineering, and Baltic Workboats. Tracia Engineering has been supplying ferries to Malaysia for years, building up a good reputation for themselves by selling more than 300 ships to over 30 countries. Their vessels might have a longer range than our electric boats, but our vessel wouldn't need a very long range for transportation to and from schools. For their disadvantages, they use combustion engines and diesel fuel, which are overall louder than their electrical counterparts and less, of course, ecological and reliable. And their combustion vehicle would typically need more repairs than an electric one and could run the risk of leaking, which could harm the ecosystem even further. Another competitor is the Turkish Sefine shipyard, which has already employed the use of their 100% electrically powered vessel in Norway. They have the record for the largest entirely electrically powered vessel and have the most research behind large electrical propulsion systems. However, they only have one electrically powered vehicle, which would make it hard for them to start implementing their vessels in other countries.
In terms of local competition, we hold an advantage as our product has a double surface with its purposes in school and tourism. It serves schools as transportation, getting students from home to school and from school to home safely, as well as in tourism, helping tourists travel around while dining and enjoying outdoor view on the deck. It also is communal in that the seats are designed in a front and back manner that encourages conversations and gives the boat a more communal feel. It is also functional. Taking the tables, for example, students can do their homework as they travel to school, and tourists can dine as they travel to their destinations. In addition, our double hull feature provides a competitive advantage as it has increased aerodynamic stability and safety. Our product is also recognizable. The external design is already commonly seen in catamarans, so it will feel familiar and safer to riders. It's also mass manufacturable. The boat has a very simple design, and the simplicity of electric systems in comparison to combustion engine and fuel systems makes our watercraft easier to manufacture and need much less maintenance. It also has a high capacity. It has the ability to hold at least 48 people with the potential to be doubled if the tables are to be removed.
As for the financial projections of our product, from our initial marketing and outreach, we hope to acquire small purchases of 2 or 3 boats from 1 or 2 government agencies or private or public floating schools in Malaysia. With manufacturing costs of maybe 170,000 and an initial launch price of around 220,000, we would be able to both market the feasibility of our product and also make enough profit to help fund our growth. Once our product is proven in the field, we can then grow to more schools, school systems, and governments, and then maybe sell around 9 more boats to governments and schools in the succeeding year for them to use in transportation and tourism.
In conclusion, the problem at hand is the lack of efficient and functional transportation for students who attend floating schools in remote areas of Malaysia. We believe that our solution is a great fit for the problem as it provides a high-capacity, multifunctional, and sustainable transportation for students and beyond. Our design is presumably easy to manufacture and more accessible for the local communities to purchase and utilize. It will also generate income for the community through its tourism-related services, which can further fund the government to purchase our products or improve our services. As we close this presentation, we would like to thank our mentor Heston Smith and all the other mentors and instructors for guiding us throughout the program and giving us all the tools for developing our product.
During this program, I gained valuable experience and confidence in 3D design and collaboration, as well as learned so much more about the marketing and entrepreneurship side of product design. I can't wait to continue to pursue innovation and use the skills that I learned in the last 4 months.
And I developed some 3D skills which at the beginning of the program I had no familiarity with. This has helped me expand my passion in design beyond just simple UX and UI design and more into full product development. I also learned the essentials of becoming a young entrepreneur and how to market myself through different methods and media. I hope to apply these lessons in the future as I pursue a career in tech design and hopefully developing my own product. Thank you, Professor Jennifer S. Tucker, for teaching us business professionality and bringing in guest speakers to inspire and mentor us. We're also grateful for the program coordinators, Budi Mulyo, Asaya Bune, and Diana Fairbanks for giving us an opportunity to use our creative skills to address such a global issue. Our gratitude also goes to our fellow interns who gave us feedback and supported us to do our best. So thank you all for guiding us in our journey to becoming future founders.